Have you ever wondered what the world would look like if the most powerful natural dam on the planet finally decided to give way? It is a question that scientists have been dreading for decades, and now the answer is no longer a distant possibility, but a ticking clock we are all watching in real time. If you value understanding the complex reality behind the headlines, before we dive into the science of what is happening at the bottom of the world, take a moment to join our community. Click that subscribe button, hit the notification bell, and share this video with someone who values the truth over the noise, because the story you are about to hear is one that every single one of us needs to grasp. When we talk about the Thwaites Glacier, we aren't just talking about a block of ice, we're talking about a structural pillar that holds back a significant portion of the West Antarctic ice sheet. For years, the scientific community has been monitoring it with a mix of fascination and dread, eventually giving it a nickname that sounds like something out of a disaster movie. The Doomsday Glacier. But why? The reality is much more nuanced and perhaps even more unsettling than the Hollywood version of events. Thwaites is massive, roughly the size of Great Britain, and it functions as a critical check on the flow of ice from the interior of the continent into the Southern Ocean. For as long as we have been studying it, it has been in a state of slow, creeping decline. But in the last few years, and particularly within the most recent months, the data coming back from satellites and remote sensors has shifted from concerning to something that keeps glaciologists up at night. The new warning is not about a sudden catastrophic collapse tomorrow morning. That is not how physics works on this scale. Instead, the warning is about a threshold being crossed. The researchers monitoring the glacier have been focused on a specific floating section known as the eastern ice shelf. Think of this shelf as a doorstop, or perhaps better yet, a cork in a bottle. This shelf of ice is grounded on a ridge beneath the sea, providing a stabilizing force that slows down the flow of the entire glacier behind it. For years, this shelf has been weakening, cracking, and thinning, but the latest reports indicate that the structure is no longer just degrading. It is poised to break apart entirely, and quite possibly within the current year. This is the point where we need to be very precise. When a scientist, people who typically speak in the language of decades-long probabilities and statistical likelihoods, starts using words like imminent or definite, you need to pay attention. We are witnessing a structure that has been in place for a long time, quietly holding back an enormous reservoir of ice, finally reaching the point where its structural integrity can no longer hold. The question on everyone's mind, and the one the researchers are trying to answer, is what happens when that cork is pulled? To understand the mechanics here, picture the Thwaites Glacier not as a static object, but as a frozen river. This river is moving. It is grounded on a bed that dips below sea level, and it is under immense pressure from the millions of tons of ice sitting behind it, all pushing toward the ocean. If you remove the floating ice shelf in front of it, the section that is currently acting like a brake, the glacier is not going to suddenly accelerate to the speed of a racing car. It is a massive, heavy, frozen system. But what it will do is lose its resistance. The brake is removed, the doorstop is kicked out, the flow of the glacier into the sea will inevitably speed up, and the difficulty of slowing that down, once it has reached a certain momentum, is nearly impossible. This is why the scientific community is so focused on the eastern ice shelf. It is the last real barrier. Monitoring teams have been using high-resolution radar and GPS instruments drilled directly into the ice, and the results are consistent across every single test. The cracks are not closing. The ice is not healing, it is fracturing, and the speed at which it is fracturing is accelerating. In some areas, the ice is moving significantly faster than it was even just a year ago. We have to be honest about the timeline here. If this shelf shatters, the sea levels around the world will not rise by several feet by next Tuesday. That is an exaggeration that only serves to make people dismiss the real danger. The ice shelf itself is already floating, displacing its own weight in water. If an ice cube melts in your glass, the water level doesn't change. The danger is not the shelf melting. The danger is the shelf vanishing, which allows the glacier behind it to start sliding into the sea much faster than it was before. This is the crucial distinction that separates reality from panic. And that is why it is so important that we don't just consume the headlines, but understand the mechanism. The researchers who study this don't do it because they want to scare people. They do it because they are watching a system that is fundamentally changing. They are seeing evidence that the natural pace of decline has been replaced by an accelerated, forced retreat. And this isn't just about Thwaites. Thwaites is the keystone. If it destabilizes and retreats, it can potentially destabilize the glaciers around it, creating a cascading effect that touches on the rest of the West Antarctic ice sheet. This is why, even if the timeline is measured in decades or even centuries, the imminence of the trigger event, the loss of the ice shelf, is a scientific all-hands-on-deck moment. It is the beginning of a process that, once triggered, is effectively irreversible, We are watching a physical experiment play out on a planetary scale. We have our satellites in space acting as cameras. We have our robots on the seafloor acting as probes. And we have our supercomputers running models that try to predict what happens next. And the scary part is not the uncertainty of these models. It is the fact that the models which most accurately predict the past behavior of the glacier are the ones predicting the fastest and most significant collapse in the future. Usually in science, we hope that the most extreme models are the outliers. Here, the most accurate models are the ones that paint the most challenging picture. This is a story about the fragility of systems we once thought were permanent. Antarctica has always felt like the one place on Earth that was immune to the chaos of our warming world, a vast, white, frozen expanse that existed outside of human time. But that illusion is fading. The glacier is moving. The ocean is warming. And the ice is responding. It is a slow-motion reaction, but it is happening. And it is happening because of us, and because of the heat that has been building up in the deep ocean, hidden away from our eyes until now. When you think about the vastness of the ocean, it's hard to conceive of it as a place where heat can be trapped. But that is exactly what is happening. The oceans have absorbed over 90% of the excess heat generated by greenhouse gases over the last century. That heat hasn't just disappeared, it has been distributed throughout the water column, sinking deep, finding its way into currents that travel thousands of miles. Eventually, that heat finds its way to the Southern Ocean, and specifically to the cavities, beneath the Thwaites Glacier. It is a slow, invisible, and incredibly effective process of erosion. The water warming the base of the glacier is not the surface water. It is deeper, warmer water that is able to reach the grounding line, the point where the glacier lifts off the bedrock and starts to float. This is the Achilles heel of the glacier. By melting the ice from below, the ocean is undermining the structure, loosening its grip on the seafloor and reducing the friction that holds the glacier in place. This is not a localized, isolated issue. It is part of a global, interconnected ocean system that is simply doing what physics dictates, absorbing energy and releasing it where the structure is most vulnerable. There is a profound human curiosity that drives this research. We are not just looking at ice, we are looking at our own future. We are looking at the maps of the coastal cities we inhabit, the Londons, the Miamis, the Shanghais, and we are trying to understand how their coastlines might shift in the coming decades. This isn't about blaming individuals or pointing fingers at specific countries. It is about recognizing that we have set in motion a series of physical events that we are now struggling to understand, let alone control. The scientists who have dedicated their lives to this, who have spent months on research vessels in some of the most inhospitable conditions on the planet, are not doing it for the thrill. They are doing it because they feel a deep responsibility to document the truth. They want us to know not so we can succumb to nihilism or apathy, but so we can face the reality with clarity. When a researcher says that a glacier is retreating faster than any model predicted, that is not an invitation to panic. It is an invitation to pay attention. It is a call to look at the data, to understand the mechanism, and to recognize that we are living in a time of unprecedented change. This is the kind of story that requires a community of people who are genuinely interested in the world as it is, rather than how we want it to be. If you find this breakdown helpful and you want to continue exploring the complex science stories that define our era, consider becoming a supporter of this channel. A simple way to do that is to hit that subscribe button if you haven't yet, and perhaps leave a comment below with your thoughts. Is this the kind of deep dive you were looking for? Your engagement helps us reach more curious minds who, like you, prefer the unfiltered truth to the polished headlines. It is helpful to go back and understand the history of this retreat. We often talk about climate change as if it were a new phenomenon that started 10 or 20 years ago, but the data from the Thwaites region suggests something quite different. Using data collected from ice cores and remote sensing, researchers have been able to reconstruct the history of the region, and they have found that the retreat of the Thwaites Glacier likely began as far back as the 1940s. This is a staggering realization. It suggests that we are looking at a process that has been unfolding for 8 decades, quietly gaining momentum, largely invisible to the public eye, until it finally reached a scale that could no longer be ignored by the satellites that watch over our planet today. The trigger for this initial retreat in the 1940s is believed to have been a powerful El Niño event. This brings up an important point about the nature of our climate. We often think of climate as a collection of steady-state systems, but in reality it is a series of interconnected dynamic cycles. A single, powerful weather event can provide a nudge that pushes a system into a new state. Once the Thwaites Glacier began to retreat, it entered a new dynamic. The warmer water began to penetrate deeper, the ice began to thin, and the glacier began to accelerate. It wasn't that the 1940s event was the sole cause of the collapse we might see today. It was that the event pushed the glacier past a critical threshold, and the subsequent warming of the planet has kept that trend moving in the same direction, compounding the problem year after year. This refutes the idea that the retreat we are witnessing is merely natural variability, while it is true that ice sheets have expanded and contracted throughout geological time. The pattern we are observing now is not a wobble. It is a directional, accelerating retreat. It is a process that has been forced by long-term changes in our global climate, which are in turn driven by the accumulation of greenhouse gases. The physics is clear, and the data is consistent. When you look at the velocity of the ice, the thinning of the shelf, and the temperature of the water, every single metric points to a system that is being stressed beyond its capacity to maintain equilibrium. This is also where we see the importance of good science. Good science is not about confirming what we already believe. It is about challenging our own assumptions. For instance, there has been a significant amount of debate in the scientific community about whether the ice cliff failure mechanism, the idea that the sheer weight of the ice makes it structurally unable to support itself, is actually as likely as some early models suggested. Some researchers have argued that the physics of ice flow are more complex than that, and that a sudden cataclysmic collapse is less likely than a slow, steady, persistent retreat. This is not a sign of confusion or incompetence. It is a sign of a healthy, functioning scientific process. Researchers are debating the rate and the mechanism of the collapse, not the fact of the retreat itself. They are rigorously testing their models, questioning their assumptions, and constantly refining their understanding. This is exactly how science should work. And yet, even with these disagreements, the consensus remains. The Thwaites Glacier is in trouble. Whether it collapses in a sudden dramatic event or long drawn-out decline, the end result is the same. The barrier is failing, the glacier is speeding up, and the sea levels are going to rise. This brings us to the concept of the keystone. We have mentioned it before, but it is worth exploring in more depth. In an arch, the keystone is the central stone that holds the entire structure together. If you remove it, the whole arch collapses. Thwaites is the keystone of the West Antarctic ice sheet. Behind it, there are other glaciers, held in place by the same topography and the same structural dynamics. If Thwaites destabilizes and flows into the ocean, it could create a drawdown effect. The ice behind it, which is currently resting on the bedrock, could start to flow toward the vacated space, increasing the overall contribution of the West Antarctic ice sheet to global sea level rise. This is the multiplier effect that keeps scientists awake. We are not just talking about the ice within the Thwaites Glacier itself. We are talking about the potential for a much larger volume of ice to be released into the ocean. Estimates of the potential sea level rise from a full collapse of this region vary, but some projections put it in the range of several feet. When you consider that millions of people live within a few feet of the current high tide line, you can see why this is not just a scientific curiosity. It is a humanitarian issue of the highest order. This is also where the human psychological element comes into play. We are inherently bad at processing long-term, slow-moving existential threats. We are hardwired to react to immediate, visible dangers. A predator in the bushes, a fire in the house. We are not hardwired to react to a glacier, a continent away that is melting at a rate that is barely perceptible to the human eye, but that will have catastrophic consequences in the next century. This cognitive bias is exactly why the Doomsday Glacier moniker is so seductive. It gives a face and a name to a threat that is otherwise too abstract and too slow to easily grasp. But the danger of the Doomsday label is that it encourages a binary way of thinking. It makes us think that we are either doomed or we are fine, and that is simply not the reality. The reality is that we are in a period of transition. We are living through a time where the decisions we make now, both as a global society and as individuals, will determine the severity of the consequences that our children and grandchildren will inherit. We are not facing a binary outcome. We are facing a spectrum of possibilities, and where we land on that spectrum depends on the choices we make. This is where the power of information comes in. By understanding the science, by learning about the mechanisms of ocean warming, by recognizing the difference between a century-long collapse and a decade-long catastrophe, we become more resilient. We become more capable of making informed decisions. We become less susceptible to the paralysis that comes from unadulterated fear, and more capable of engaging in the complex, difficult, but necessary work of adaptation and mitigation. This is why we need to talk about the data, not the drama. When we strip away the hyperbole, what we are left with is a story of incredible, almost incomprehensible planetary physics. We are talking about billions of tons of ice, thousands of miles away, being fundamentally altered by the thermal energy stored in our oceans. It is a testament to the scale of our impact on the Earth, but it is also a testament to the resilience and complexity of the planet itself. If you have stayed with us this far, you are clearly someone who values depth over clickbait. If you appreciate this kind of thorough, grounded analysis, take a second to consider a different kind of call to action. Share this video in a space where you think people need to hear a calm, rational, and evidence-based breakdown of what is happening. Sometimes the most radical act is not shouting, but simply sharing the truth. Now let's look at the broader context of why this keeps happening. Why is it this specific glacier? Why Thwaites? The answer lies in the topography of the West Antarctic basin. Most of Antarctica is a continent covered by ice, but West Antarctica is different. It is essentially a collection of islands covered by a thick ice sheet with a basin that dips far below sea level. This means that the ice is not just sitting on land, it is grounded on rock that is submerged. This is the critical vulnerability. As the glacier retreats, it moves into deeper water. This exposes more of the glacier to the warmer ocean water, which leads to more melting, which leads to more retreat. It is a positive feedback loop. The further back the glacier goes, the more exposed it becomes and the faster it melts. This is what scientists call marine ice sheet instability. It is a runaway process. Once it starts, it is very difficult to stop, and it doesn't require any further external force to keep going. It becomes self-sustaining. This is why the researchers are so concerned about the grounding line. The grounding line is the boundary between the ice that is resting on the seafloor and the ice that is floating. If the grounding line retreats, the area of the ice that is in contact with the warm water increases. This is the engine of the collapse. And the data from the underwater robots confirms that the warm water is reaching further inland than we ever thought possible. It is pushing miles underneath the ice, eroding the foundation of the glacier from the inside out. This is a structural problem that cannot be solved by a fix in the traditional sense. You cannot go to Antarctica and pour concrete to hold the glacier back. You cannot build a wall to stop the ocean currents. This is a planetary scale system that is responding to planetary scale inputs. The only solution, if we can call it that, is to address the root cause, the global temperature increase that is driving the ocean warming. But that is a conversation for a different day. Today, our goal is to understand the glacier itself. And the most important thing to understand is that the glacier is telling us a story. It is a story about the consequences of our actions, the complexity of our climate, and the inevitable reality of physics. It is a story that has been writing itself for 80 years. And it is a story that is entering its most critical chapter. We often think of the environment as something out there, separate from us. But the Thwaites Glacier reminds us that we are part of the same system. The greenhouse gases emitted in our cities are the same gases that contribute to the ocean warming that is melting the ice in the Antarctic. The connection is direct, measurable, and unavoidable. We are part of the loop. This is why the study of this glacier is so profoundly important. It is not just about the ice. It is about the interconnectedness of our world. It is about understanding that a decision made in a boardroom or policy made in a capital can have a ripple effect that travels across the globe, all the way to the Southern Ocean. It is about recognizing the weight of our collective choices. And as we watch this, we should be careful not to fall into the trap of cynicism. Cynicism is easy. It is the refuge of those who don't want to engage with the complexity of the world. It is the easy way out. But the scientific community, despite the gravity of the situation, is not cynical. They are engaged, they are working, they are measuring, they are debating, they are trying to figure out how to best communicate the reality of the situation. That is a form of hope. It is the hope that if we understand the problem, we can find a way to deal with it. There's a powerful image that researchers often use, the image of a tipping point. It's the idea that a system can remain stable for a long time, absorbing stress, until it reaches a point where it can no longer compensate. At that point, the system fundamentally changes. It transitions to a new state. We are seeing evidence that the Thwaites Glacier may have reached such a tipping point. And the fact that we are witnessing this in real time, with all the tools of modern science, is an extraordinary, if unsettling, privilege. We are, in a sense, the witnesses of a major geological transition. Future generations will look back at this time, the time when we first recognized the instability of the West Antarctic ice sheet, and they will ask, what did we do? Did we look away? Did we panic? Or did we try to understand? The answer to that question is being written now in the way we talk about these stories, in the way we educate ourselves, and in the way we prioritize the truth. So, as we conclude this exploration, take a moment to reflect on what you have learned. The Thwaites Glacier is not just a block of ice. It is a mirror. It reflects our impact on the planet, our vulnerability to the systems we rely on, and our capacity to observe, to understand, and to respond. The glacier will continue to move whether we watch it or not. The ocean will continue to warm whether we acknowledge it or not. The ice shelf will eventually break, whether we are prepared for it or not. But by paying attention, by learning, and by engaging with the reality of the situation, we are doing something vital. We are acknowledging the truth. And in a world that is increasingly cluttered with noise, acknowledgement is a powerful, necessary step toward wisdom. Thank you for being part of this exploration. This channel is committed to bringing you the stories that matter with the care and the precision that they deserve. If you have found value in this deep dive into the Doomsday Glacier, remember that the best way to support the work is to share it. Send this to a friend, discuss it with your family, or just take the time to think about the concepts we have covered. We are all in this together on this fragile, beautiful, and ever-changing planet. The final takeaway is this. The warning issued by the scientists is real, it is grounded in evidence, and it is a reflection of a system that is in a state of flux. It is not a call to despair, but a call to awareness. We are living in a time of great consequence, and the story of the Thwaites Glacier is one of the most important chapters in the book we are writing for the future of our world. Stay curious, stay informed, and above all, keep looking for the truth in the data, because that is the only map we have to navigate the uncertain waters ahead.